that it's saying. The key things are sort of look at the where you are taking that measurement. Why is it failed? Why is it likely to fail? Well, it's going to be any sort of magnetic interference. Cell phones in your pocket, okay, would be yeah, anything like that.
Here shows the air photo of the measured location in the morning. So this is the measured location. We use the moving format.
Is that all you've got of that image? You don't have what's upstream a bit more? No.
So you just mentioned that if the flow come here,
Yeah.
curve. So this is the left hand side, this is the right hand side.
Yeah. Oh, just a I don't know. Sorry. News. I think that the channel probably does this. Does it?
After that we can check.
This is the bit that we're showing, yes?
No.
No?
The way we show is
Is that okay?
Yeah.
And this is the channel. Yeah.
Yeah. Yeah. A little bit.
A little bit of a bend.
Yeah,
So
yeah,
it's
yeah.
come here and it's just
Yeah, yeah.
and it's deflected off and that's why it's scoured out that side.
Makes sense. Thank you. So, and then we can talk about David's project.
Okay. If we you will see that in here it's turned green and it's been checked, saying that we've done these tests.
Okay.
Okay.
So everything has been done.
Everything's been done.
And
If I was to open a file, one of the later files,
open
let's
which
say
one?
this one.
Information.
Okay.
That's the first one.
This is file number 0628. So I've just opened ending 06. Okay, this is the one that we did immediately upstream of the structure, the control. Okay, so after we've done the stationary measurement,
Oh, yeah.
okay, and we very quickly set up that instrument. You know, we didn't put any parameters in, we didn't put a transducer depth in, we didn't do a system test, and I can see that straight away that we didn't set the time. The markings here are saying red, hasn't been turned green, no system test, no compass calibration done. The fact that we've not done a compass calibration doesn't matter, because the compass calibration is still valid. Okay? But we could sort of just say, okay, if I want to open a compass cal, and I'm going to say, what's the second one?
Second one.
Yeah. So, although it says it's not had a compass calibration, it still records when the compass calibration it is actually using. Okay. So it says that the compass calibration occurred at 11:02 on the 22nd of May, and this is what the calibration error was.
The second time.
That was from the second one. Okay. I'm just going to take that one out again for the moment. And over again.
So you will take out this file for discharge technique.
Sorry, just moving now. Which ones was it?
G0628.
I don't see. Okay, so the next thing I start looking at, if I do Control and S, which is the summary, I immediately what I start looking at the actually if I just expand it a bit, we will see all the files. We'll see what the discharge values are, and we'll see that for those 8 measurements we have a coefficient of variation of just about 7%, 6.9% down here. We know the last 2 are probably unreliable because we've done them very quickly. So I can take those out of the calculation. So if I uncheck the box on the left-hand side, they are no longer put in the calculation. Okay. They are now at 0.07. It's actually made it worse. Reason it's made it worse is it sort of it's made the first 2 measurements more influential on the overall score. The first 2 were potentially an error because we'd set the instrument up that with the start edge, it would automatically, after 10 seconds, it would automatically go into transit mode.
Yeah.
Okay? And on the first 2 measurements we did, we held the boat stationary at the edge for a very long time. Okay? And so in that transit mode, there was a lot of error sort of being brought into that. So I might just sort of choose that I don't want to use those 2. And we did make that's why we made the decision to do the extra transits. Okay, rather than just doing 4, we said, okay, we're going to do another 2.
That's right.
To take out the effects of those first 2. So I've take out of those 2, and now if that's the middle 4, which is the ones that we were considered we were doing correctly, we now see we have a mean discharge of 1.473 with a coefficient of variation of 1.3%. 1.3%. Okay. Standard deviation on the measurement is around about 19 litres per second. So you know that's a really good score.
Yeah.
Okay. It's only a really good score if the data's any good. Okay, but it gives me confidence that it's good. The other things I like to check are the DMG, the distance made good. Okay, so as the boat, explain the difference between the 2. As the boat is going across the channel, it can be doing this. Okay, this is our river edges. The total distance here is what we call the track. We have the start point here, A, and the end point here, B. DMG is the straight line distance between A and B. So all the way it's going, every time we're going along we get a track value, and then we also get a DMG value, which would be that point, that point, that point. Okay? If everything's working well, your DMG value, this A to B, should be the width of the channel. So that's telling us we have a DMG of 7 meters, just about 7 meters, with a variation of 1.6%. Okay? So that's pretty good. You'll see that the next column along after DMG is width. So DMG is what it's the intrinsic bit. The width is adding on the edges as well. So that's the total width. Okay? So that's the bit where we told it how wide the extra bit was.
How quick of the channel? The width?
The total width of the channel. Total width of the channel, including these edges. Including the edge area. Okay?
So that's the weighted surface, not the weighted
It's
top surface.
the top surface of the water, total top surface of the water. And we put into the instrument that it was 0.5 meters on each side. Okay? And you'll see that the width is 1 meter wider than the DMG. Yeah, in the DMG it only goes to 2 decimal places, and in the width it goes to 3. So the other one's just rounded a bit. Okay? So I checked those. They shouldn't vary too much, particularly on a channel like we had today.
So the standard deviation should be less than
2 to 5%. 2 to 5%, depending on the channel. Okay.
Big channel.
Big channel, yeah, or maybe there's sort of a lot of vegetation around, or the trees, or and all that rock. That can make it.
So the deviation in the deviation less than 5%, so we can say the quality is good.
Yeah, yes.
Okay. Before that,
Especially if with today, where we were very, we didn't move from the side. Where you will often see an issue. So we had one person here controlling it and one person here controlling it. And we knew pretty precisely where the boat was at its start and its finish. Okay? Sometimes what people do is they put the rope across, and they have a pulley system here. And the rope comes back here, and you're controlling it just from this side. And you actually don't fully really know how close you got to that edge.
Oh, I see.
Okay, and so your DMGs are sort of are a bit less consistent. Yeah. Okay, so that then becomes it. So if I know it's being operated only from one side, I would be less worried about the DMG being so consistent. Okay. However, if you're doing it from one side, you really should be trying to find another way of measuring how close it is to the edge on the far side. And typically, I carry in my box a laser distance finder, and I aim at the instrument, take the reading, and then aim at the bank and take a reading, and then I get the distance from the edge. Yeah. We should also be looking at mean speed of the water. If it's a pretty consistent flow and there's no sort of real pulsations in the water, you would again expect that the mean speed of the water to be pretty regular. Where we've probably got our error in the first 2 measurements, the ones that we're not using, is that the mean speed is lower. And that's because we've biased it so much lower because we had all that time over in the eddy, okay, on our edge distances.
I can say here that this mean velocity, this mean speed, if we had an SL or an IQ, we would take this data here and then do the regression for the side-looking Doppler or the IQ. This is what we would do the indexing. We would take this value.
Indexing,
right. Then we would take that and put together with the SL data, the IQ data, to make a rating for it.
Another thing that people often say is this one at the end, the measurement percentage. Okay, it shows that we measured around about 58% of the channel. Okay, so with the edges that we've not measured, with the 10% that we're not measuring at the bottom, with the blank distance, and with the the blank and the transducer depth.
Yeah.
Okay, that accounts for 42% of the channel that we've not measured.
Is it okay?
If you think about a mechanical meter,
Uh-huh.
you probably measure, in that same situation, you'd probably be measuring something like 10 to 15% of the channel. And we accept that. So we've massively increased the amount we are measuring. I've seen good data down as low as 30, 35%. Okay? Do I trust, would I always trust it? No. I think once you get below 50%, I would start to look for a different site.
Okay.
Okay, where it's a bit deeper. Okay, and we can measure more of the velocity. Okay. But if it's the only site that you can possibly go to, then just spend a bit more time at the site, ensuring that you do as good as possible a measurement, and then you can sort of say with a lot more confidence, actually no, even though we've only got 40%, 35%. When you then look at all the rest of it, your total cues, the deviation, the variation between the measurements and everything else that gives you confidence, you say, no, I can accept this. Okay. If I just quickly go to the manual, okay, so embedded into the software is the manual. Somewhere. Okay, view documents where we've got this question mark here. And if you go to view documentation, okay, so this is 3.80. And if I just go down to somewhere. Okay, 8.5, processing data files, step by step. Okay, if you were to work your way through that wouldn't be a bad thing to do. Okay, so in your very first times that you're doing some checks, it'd be good to print that off and have it beside you, and just run through all of those things there. In time, you get a better feel for looking at the data, when data's going to be good, when data's going to be bad.
I have a question about how to change the angle.
Okay. So you'll say, okay, so we don't need to change it on this one, because this was all okay.
Okay.
Okay, but if I wanted to change it, what I would look to is I would go down to the bottom here with the GPS. I would look at the GPS ports, GC to BC. Okay, and it says that there's 0.2 of a degree, the difference. It's nothing. Okay, it's well inside the 2 degrees that is the specification of the car.
But the same data shows on the computer
On 2507,
yeah, 2507.
and it's showing 0.5.
And my second connection is -3. I think you change to -3.9.
Yes.
So why can I change it?
Okay, if you do Control T to get the toolbox, or Control T, or up here, there's the tool symbol. If we click that, we can bring up the toolbox.
Yes.
Okay, and if I do the drop down, I look at heading correction and GPS offsets.
Heading correction.
It's actually 3.9. No?
Oh yeah, heading correction. Yeah. Okay, apply. Apply to what?
Apply, well, yes,
Because
it is magnetic, it is used in the same place, so apply to all. So that will apply to all files that are open. Okay. One of the reasons you might have a different value, sorry, is you're using new Compass data on the old software. Oh no, you're using 3.8. You are.
The GC to DC shows in my computer is 1.
Yeah, it is on mine now. I've changed it to 3.9. I've now got GC BC of 1 degree.
Okay, same.
Okay, so if you did want to make that change to totally correct it, we know that it's 1 degree from this. If we go to SonTek Compass heading correction, and we put in there 1, and we apply that, but we only apply it to this one file, not to all.
Okay.
Okay. Mine now changed down to 0.1 of a degree.
Oh, so you have to do twice. First of all, you make sure you make a declaration.
It's there, it's set.
And you check that GCBC,
See.
then you check the correct stuff.
Yeah, and then you see that.
Okay.
At this side, I would not have changed them. There's no need.
No need.
Okay. The compass was in good alignment to the GPS.
Yeah. So will it affect the discharge result?
Well, if we have a look up on the screen, we have a discharge of 1.2.
Discharge 1.225.
Yeah, for that one 1.225. If I sort of take that 1 out,
Set it 0.
set it back to 0, and apply 1.226, 1 litre.
No, not so much different.
No.
Oh, okay.
Okay, if there had been more of an error, let's say there was 5 degrees.
5 degrees.
Okay. Nothing. Okay.
But the connected determination is 7 meter. You use 7 meter, you need a fair amount.
Because we are actually, because we're calculating off the bottom track anyway. If we had gone to system settings, then we've been using, say, GGA, apply that one, we go to 1.202, and then if I do the correction, minus 3.9, apply that, 1.234, and then if I do DC minus 1 degree, apply. We go 1.226 again. So that comes back. When we do those corrections, we come back to the same as what the bottom track was saying.
Okay.
To within 1 litre. Yeah. So that is, as I was saying, it's the magnetic declination and the compass alignment are critical when you're using GPS data. When we're using the bottom track, it's not so. Now just run through this again. So here, track reference, whatever you've selected here, bottom track, GGA, BTG, okay, will change how the calculation is carried out. So if I do GGA here, and I just apply that one, I'm just going to do Control T to close that. If I do Control S, you will notice on the screen that we have bottom track being shown here, but the top one has GGA. Really, another qualitative check would be to check that they are all the same. You should be using the same track reference for all of those. Okay. You should also really have, we go left, this one's right to left, left to right, right to, you know, they should alternate. Left to right, okay. You shouldn't have left, right, left, right, left, right, okay. That's it should be changed. Okay. It's also showing that we're using the vertical beam as our way of calculating the depth. So if I bring open the box again, and if I go here on bottom track, if I apply that one, we now see that the top one is using GGA and 4 beam average. And as a very quick reference, we can see that. A couple of things we can just quickly do. If we want to export this discharge summary, okay, just click this button here, give it a name. Save. Oh, whatever. I'm just, yeah. And then if I go to Word. Files, and then we got the summary. No, wrong one.
Yeah,
It's BIS. Yeah, it's not come out word in word. Well, in word.
You can put a, you can right click on it.
You could, yeah. You're saying just use it from here.
Yeah,
Save to clipboard.
yeah. You show how to do that.
Yeah. And then we could have been in Excel. I just open up Excel, Control, paste it into Excel. Something else we can do on any of the graphics. So if we decide we like this graphic, right click, save to clipboard. And then if I just open up that Excel file again, put that down here. Okay, we've got.
It's nice when we can work reports.
Yeah.
Right click and then save the paste clipboard.
Another thing, while we're just on this subject, if we go to samples, and we see here we've got the 1 second average for each sample. So it's like where it says velocity and everything, it's the mean velocity for the channel for that 1 second. It's not the individual cells. Anything that you have shown you've got listed. Okay, if we do right click, save to clipboard, and again, in Excel, it will then paste that in. It's just a quick way of getting that data out. But if that parameter is not listed up here, it will not be sent out. Some people, when they're doing they're using the instrument not to do a velocity, they're actually doing it just to do a contour of the channel, the depth of the channel. They will just actually have DMG and depth plotted, okay, and then in there and export those two, and you very quickly got in an ASCII file your distance across and depth. No, there's a couple of other things. I was just okay. Yep. If I go back, bring the toolbox back up. If you want to export the data to ASCII, or you want to export it to MATLAB, if you go up to the top here, the button here, export to MATLAB. Drop that down. You can either export the one file that you have on screen, or you can export all of the ones that are open. Okay, and that will automatically do that. And the same with the one beside it for ASCII. You do need to remember though that those exports will only be, it will not be all of the data, it will only be however you've set up here. So I'm looking here at the track reference of GGA, depth reference of bottom track, and the coordinate system ENU. That's the only data that will be sent out to that ASCII file. It won't be the bottom track data as well, or the BTTE data as well. Okay.
Oh. So
Okay.
before you
So if you want to see all of that, you would have to do 3 exports. Okay. I think MATLAB doesn't take it. No, I don't have MATLAB, so I can't see it. So I've never been able to test that. MATLAB certainly takes more of the data,
Yeah.
for sure. Okay. No, I just want to, just the other things, I'm just going to go down through here. We deliberately, I haven't opened them yet, we deliberately, when we did the last 2 measurements, deliberately set them up incorrectly. Okay, so we see here it says that when we've tried to open the one that says missing sample files, it's saying that some is, it will allow me to open it still, and I can still process it. But you see here, it says that the discharge is negative.
Yeah.
Okay, we have minus 1.077 and minus 1.074. That's because we started the measurement on the left-hand side of the river, and we went across, but we told the instrument we'd started on the right-hand side.
Yeah.
Okay, and then on the other bank, we started on the right, and we were told it was on the left. We can change that quite easily. First of all, not there, sorry. If you go back to the smart page and you go into edge settings, and if we, at the top we have start edge. So I'm going to change that one to right bank, say OK, that becomes positive now. And if I click the other one, wherever it is, some samples. If I go again to edge settings, change that to left bank, say OK, and that becomes positive too. Something else that we didn't do, we hadn't put in a transducer depth. So it was thinking that the transducer was directly at the water surface. So I can just change that now. And instead of saying 1.077, by putting in an 8 centimetre transducer depth, it now says the total Q is 1.263. Okay, so it's quite a significant error that would have given us if we hadn't put that in. Similarly, maybe our transducer depth that we put in was wrong, and we haven't checked that.
Yeah.
Okay, but you could just sort of say, okay, I know all of them were wrong. I know it was actually, let's say, 6 centimetres, and I can say, once I've opened them all, I can click apply to all, and that will change that 6 centimetres on everyone.
Where can I change the
Transducer depth, if we go system settings, so on the toolbox, so Control T or the toolbox, system settings, and the top one is transducer depth.
Okay. So, turn.
I don't think it was as deep as that. I think it was around about 7 or 8 from my
7,
experience.
7.
Yeah. We'll just run through that. So screening distance, if I
5 centimeters?
I'll just show you. So we have here, we'll see this black white bit at the top. That's the bit that's the unmeasured portion. I'm going to increase that now to 20 centimeters. Okay, and I'm just going to apply it to that one. I say and it drops down.
Yeah.
Okay, that's from the downstream one. Good. Good. Okay, and so we're now extrapolating more of it. The difference is 1.239 is when I'm extract with the screening distance. Let's go a little bit deeper, 0.3. Right. So we're now, it goes now 1.23. You know, so the extrapolation is actually working really well. We're lucky at this size.
Okay.
But just show, take that back to 0. Similarly, if we wanted to increase, maybe we were not happy with the bottom, how it was. So in the profile extrapolation, we could say actually we're going to go up 50%. We can apply that.
Now this could be a case where you're hitting the bottom with the vertical beam, but your velocity beams are not going all the way because they're getting absorbed by the sediment, for example. And you might be only getting the first 5 cells, and then it's so thick the mud, but you're still getting a vertical beam.
Yeah, it's still.
And you can still extrapolate through this and still get a reasonable, like this is using extrapolation here for the bottom. So that could be an example, right?
Yep, so it is.
So,
And you see how it changes. I've gone 50%. I'm sort of saying discard the last 50% of the measured portion and extrapolate it, so it's gone to 1.260. So I'll go back to the default of 10. 1.239. You know, it's not hugely different. You know, the extrapolation is quite good. This is actually the file we got up on screen, or the data, is the one from very close to the weir. Okay, the control structure. Okay, and if we look at the compass on this one, we can see that a lot more magnetic interference came in
because there's a gate.
because of that gate.
Yeah.
Yeah.
You know, stuff on the right hand side. There's
Yeah.
a gate just.
Those big metal gates.
Yeah.
You also, so for the magnetometer, that's the only output you have, or is there another parameter besides?
There's we can plot.
Magnetic intensity or something?
We can
Oh,
no.
just that magnetic.
Yeah, magnetic.
But yeah, that's significant.
It is.
The threshold we set it at,
It's 3.5%, which is around about 2 degrees. Close to 2 degrees. Again, if we're using bottom track, it wouldn't be an issue. But if we're using the compass, GPS compass, sorry, the GPS, it would be. Okay. Any question? Anything?
So far, we focus on moving forward.
We had. We're now. I was just going to open up the stationary
Yeah.
data. So I'm just going to go to River Surveyor Stationary Live. Coffee break? Tea break? Breath, leg break?
Yeah.
Yes.
washroom.
Arm break?
Okay.
好，谢谢吧。
我们休息10到15分钟，那中间有没有问题的可以请教Mark 跟Lee。那外面有茶点，可以先休息一下。
什么？ 下课睡觉。
Yes, one. Please stay there. I won't do. Just want to do this. You want to see this bit in more detail, not this bit. No, it's annoying. Yeah. In fact, we need to make notice. Again, these are all things that I've talked about in the past, but thank you. You want to, so do Zoom. You're right. I know. And it's, to me, it's so frustrating because with the old instrument, which was not as good, I just go. Old software. Okay, so old software for the old instrument. It doesn't work. It doesn't work with the new instrument. Okay.
Can you open the data today?
No, it's a shame because there's a couple of things. When we here, I could actually you can, if I say fixed distance or sorry. Okay, so